What's up, guys? So, back again here. So, I've done a few videos informally discussing terms that people use wrongly in psychology and philosophy. So, this is going to be similar to that. It's going to be sort of a midway between those. I'm going to talk about statistical terms that people use wrongly, and I might expand this as well, but I'm going to keep this one really brief. So, let's go with the first term right off the bat, statistics. Most people use that incorrectly. Statistic is not just any number or that you pull out of your ass. A statistic refers specifically to a number that can be computed from data, um, usually involving no unknown parameter. Okay, that's what a statistic is. It doesn't mean any number that people want to say for something. And because of that confusion, people always say, "Well, statistics can mean whatever you want it to be." No, it doesn't. You're wrong. Okay, and it's broken down basically in between two types of um, methods of statistics, which is either descriptive statistics or inferential statistics. So, descriptive statistics. I'm gonna get that word a little tongue tied here, so bear with me. I'm sorry about that. Descriptive statistics, excuse me, refers to looking at statistical figures and stuff like that. But again, it's not stuff that you just pull out of your ass. Okay, it it refers to data that you've collected, usually involving a random sample, stuff like that. Okay, inferential statistics refers to statistics that's not directly gathered but inferential, as the label implies. So usually it's taking that data and analyzing it using different types of the statistical tests. Sorry, I told you I was going to get that word tongue tied. But using different sorts of analyses, statistical analyses, like the bane of all students' existence in behavioral sciences, the student t-test, that's one of them, or the ANOVA, the analysis of variance, um, types of tests, and multifactorial analyses, and so on and so on. Parametric. I don't want to get into all of that on this video. Okay, but let's just say, so statistics refers to a number computed from data having no unknown parameter. Okay, and the methods of statistics, which are multiple but can be basically broken down into the binary distinction of descriptive statistics and inferential statistics. Okay, and some more stuff that people get wrongly. Often in news, sports news, the people talking about it talk about these false statistical observations or laws, like talking about the law of average or hot streaks and stuff like that. Those aren't real statistical laws. Okay, no. There's no law of averages. Okay, and there's no hot streak. A hot streak is just a variant of the gambling fallacy. Okay, when there's different variations of the gambling fallacy, but generally they refer to people who think that they can predict the outcome of random events. Okay, and so you have this with people who are gambling addicts, or people who try to bet on sports and stuff and try to say, uh, this athlete or this team is going to do this or that because they did so well in the past, or they didn't do so well in the past, whatever. And then, there's the fair question of whether sports are games of chance or games or games of skill. Um, I don't know, to be honest. Either way, I would say that in any fair game, there's always a 50-50 chance of one team or one individual winning out over the other. So you should take heed of that if you're going to bet on the winner. Okay. And like I said, the law of averages isn't real. What people might be referring to with the law of averages are maybe the law of truly large numbers, which is a statistical law. The law of truly large numbers refers to the statistical observation that given a large enough data sample, coincidence will occur. And which explains a lot of stuff that people think is quirky or weird or blah, blah, blah. So, for instance, a lot of people think they can predict bad events based on things like, oh, I had a bad dream that a plane is going to crash. And then lo and behold, in the news, you hear about this airline where they went down and crashed. And like, oh, I predicted that. No, you didn't. So because an airplane crashing is one of the most feared things that people can undergo, of course, they're going to factor into a lot of people's dreams or nightmares. With roughly, 8 billion people in the world, you can account for every day at least a couple of million people thinking or dreaming about that given day. And then there actually being a plane crash, which are actually pretty rare. But statistically speaking, but when it does occur, the fact that you have a couple of million people dreaming or thinking about it that very day, of that coincidence is going to occur because of the law of truly large numbers. That's a huge sample data of people dreaming or thinking about plane crashes, then one happens. Okay, that's the law of truly large numbers, which the law of averages is, I guess, trying to be about, but it's really not. The law of large numbers is just at best just a variation on the gambling fallacy, as well as the hot streaks and other pseudo sports statistical laws. Okay, and what since I mentioned coincidences, I should also mention that those aren't quirky either. Coincidence is just two events happen together. Coincidental events. There's nothing mystical or about it. There's nothing quirky or supernatural or paranormal or whatever. Again, given a large enough data set, you'll find two events happening at the same time. That's what a coincidence is. Okay. And again, I can go into more stuff, but statistics is, well, I've studied behavioral statistics, which was actually developed by a psychologist that took the math and made it into a separate formal science on its own, which is used in behavioral and social research. Okay, but statistics is based on probability theory, and probability theory is mostly frequentism or frequency theory. Although there's different probability theories about, like Bayes' theorem, stuff like that. However, Bayes' theorem is more about the psychology of probability than actually making mathematical predictions. So, which gets me to the last thing before I end this, which is you cannot. Well, let me put it this way: it's scientifically meaningless to predict the the outcome of a single probabilistic event. Again, dealing with frequency theory, we like to compute the probability of events that are, clustered groups, stuff like that. You can't really predict the outcome of a single event. Like, you can and you can't. You can through Bayes' theorem and related mathematical tricks like that, but they're not actually scientifically useful, put it that way. So as far as scientists are concerned, they're predicting single probabilistic events is meaningless to them, which meaningless in scientific terms means that they're not testable claims. Okay, so when people say, "What's the odds of X or Y happening?" I would just simply say, "I don't know." There's no way to predict those sorts of things. Like, again, with Bayes' theorem, you can actually do that, looking at the expected values and plan with those sorts of things. But again, it tells you more about the psychology of doing probability than actually making mathematical predictions. Okay, so that's all I wanted. Excuse me. That's all I wanted to say about that. I'll go into more statistical stuff as it relates to psychology and informal logic. Okay, but that's the base of it. We're not predicting the probability of independent events here because they would just be random. Okay, and random does not mean chaotic. So that's a topic for a different day. All right, but I'm just a contrarian.